This is Bob Capetta from the University of Illinois at Chicago, and this lesson is an introduction to rational functions. Let's examine the function f of x equals 1 over x. Our goal is to graph it. So let's create a table of values. If x is 1, f of x is 1 over 1 or 1. If f is 2, 1 over 2 is a half. X is 3, 1 over 3 is a third. X is negative 1, 1 divided by negative 1 is negative 1. X is negative 2, 1 divided by negative 2 is negative a half. X is negative 3, 1 divided by negative 3 is negative a third. Now if x is 1 half, 1 divided by 1 half is 1 times 2 or 2. 1 divided by a third is 3. Similarly for negative 1 half and negative 3. So there's the points that we've identified on the table, and you can see what's going to happen as we move up this way. The graph is going to have an asymptote that will be the y-axis. Moving down this way, the asymptote will be the x-axis. So horizontal asymptote here at y equals 0, vertical asymptote here at x equals 0. Here is our graph. Looking at that function, we can see how this is behaving. And what I want you to notice is the exponent here is 1. X equals 0 is not in the domain. The vertical asymptote is x equals 0. But on one side it's going to positive infinity, on the other side it's going to negative infinity. That's what's going to happen when our exponent is 1. That's what I call a first order asymptote. It's going different directions on either side of the asymptote. Next, let's take a look at f of x is 1 over x squared. Again, I'll make a table of values. 1 squared is 1, 1 over 1 is 1, 2 squared is 4, 1 over 4, 3 squared is 9, 1 over 9. Negative 1 quantity squared, negative 1 times negative 1 is positive 1, 1 divided by 1 is 1. Negative 2 quantity squared, negative 2 times negative 2 is 4, 1 over 4, etc. A half squared is a quarter, 1 divided by a quarter is 4. A third squared is a ninth, 1 over a ninth is 9. So let's go ahead and plot these points. 1, 1, 2, a quarter, 3, a ninth. We can see it's growing towards the x-axis and dropping very, very quickly. A half lands me at 4, and a third lands me all the way at 9. So again, you can identify the fact that we're going to approach the x-axis as x goes to infinity. And we know we have a horizontal asymptote at y equals 0 because this is a bottom-heavy rational function. The degree of the bottom is greater than the degree of the top, so the x-axis, or y equals 0, will be a horizontal asymptote. And the vertical asymptote is, of course, the y-axis, as was the case in the previous problem. But notice the difference. This has an exponent of 2. So from the left, it's going to positive infinity. From the right, it's going to positive infinity. From either side, it's heading in the same direction. That's indicative of an exponent of 2. Whereas when we had the 1 over x situation, the functions were approaching different directions on either side of the asymptote. So this is an exponent of 1 situation, and this is an exponent of 2 situation. So we need to be able to identify that. We certainly can use transformations of functions to move these. So here's what f of x equals 1 over x looks like. And let's ask ourselves, if we replace x with x minus 2, how is that going to change the graph? That, of course, is f of x minus 2, so everything will move to the right 2 places. The vertical asymptote here is the y-axis. Moving it 2 places to the right will make the vertical asymptote x equals 2, as we can see here. So all we've done is we've moved every point over 2 places, asymptote moves, and then do our graph. Similarly for this one, if I have f of x equals 1 over x squared, order 2 asymptote, 0 is not in the domain, so both of them are heading the same way. Now if I instead look at 1 over x plus 3 quantity squared, we are replacing x with x plus 3, so that means we are shifting everything 3 places to the left, 1, 2, 3. So my new vertical asymptote will be at x equals negative 3. And you can see how that behaved. Just took all of our points, moved everything 3 places to the left to graph 1 over x plus 3 squared. So try to keep in mind the general graph of 1 over x, the general graph of 1 over x squared. and then we can move those around. But we can certainly multiply those things as well. So if I have negative 2 over x, that's just negative 2 times 1 over x. So we're going to take our 1 over x table, multiply everything by negative 2. So here's our 1 over x table. 1 over 1 is 1, 1 over 2 is a half, 1 over 3 is a third, etc. But if I want negative 2 over x, every one of these needs to be multiplied by negative 2. So negative 2 times 1 is negative 2. Negative 2 times a half is negative 1. Negative 2 times a third is negative 2 thirds. Negative 2 times negative 1, positive 2. Negative 2 times negative 1 half, positive 1. Negative 2 times negative a third. Negative 2, positive 2 thirds. Negative 2 times 2, negative 4. Negative 2 times 3, negative 6. So here's my x values. There's my y values. From that, we should be able to construct a graph. 1, negative 2, x is 1, y is negative 2. See that? X is 2, y is negative 1. Similarly, negative 1, 2, negative 2, 1, and maybe a half, negative 4, a half, 1, 2, 3, 4. There's a half, negative 4. So if I multiply 1 over x by something, like in this case, negative 2, all we're doing is multiplying 1 over x by that value and then plotting accordingly. Again, I want to emphasize, notice going different directions on either side of the asymptote. That's because this is x to the first power. That's what's going to happen in that situation. But if I have f of x is negative 3 over x squared, again, the same process. This column is the 1 over x squared column. Multiply everything in that column by negative 3 to get negative 3 over x squared. Negative 3 times 1 is negative 3. Negative 3 times a quarter, negative 3 quarters. Negative 3 times the ninth, negative 3 ninths, or negative 1 third. Negative 3 times 1 is negative 3. Negative 3 times a quarter, negative 3 quarters. Negative 3 times the ninth, negative 3 ninths, negative 1 third. Negative 3 times 4, negative 12, and you get the idea. Notice these are all negative values, so I'm going to plot 1, negative 3. I'm going to plot 2, negative 3 quarters. There's 1, negative 3. 1, 2, 3. 2, negative 3 quarters. 3, negative a third. And a half, negative 12. A half all the way down to negative 12, which is about here. So flipped, multiplying it by negative 1, we're flipping it over the x-axis, changing the shape a little bit by multiplying it. But I also want you to recognize this is an order 2 asymptote, so both sides are going in the same direction. From the left going to negative infinity, from the right going to negative infinity. And this indicates an order 2 asymptote. Next, I want to construct a function for this graph. So let's look at it. Well, what do we see? I've given you a point at 1, negative 1. I have a vertical asymptote at negative 2. There don't appear to be any x-intercepts. So if the horizontal asymptote is y equals 0, we have a bottom-heavy fraction of sorts. So let's go ahead and do our analysis. Again, vertical asymptote at x equals negative 2, no x-intercepts. So I have to have x plus 2 downstairs somehow, but I don't know what this multiplier is. But I can find it by using this point 1, negative 1. So that's going to be part of our analysis. So if I have that point 1, negative 1, that means f of 1 is negative 1. If I plug 1 in for x, I get a over 1 plus 2. So let's see if that's enough for us to do the appropriate analysis. F of x is a over x plus 2. F of 1 is negative 1. F of 1 is a over 1 plus 2. F of 1 is a over 3. Well, if f of 1 is a over 3, and if f of 1 is negative 1, a over 3 has to equal negative 1. Multiplying both sides by 3, I get a is negative 3. And that will enable me to finish the definition of this function. F of x will be negative 3 over x plus 2. Let's take a look at another one like that. We want to find a function for this graph. So notice both pieces are going the same direction. So downstairs, I'm going to have a second degree, second power, vertical asymptote at x equals 1, Horizontal asymptote again, x-axis, y equals 0. So it should be a bottom-heavy fraction. So there's our vertical asymptote. So I need to have x minus 1 downstairs, but actually x minus 1 to the second power because of the way this asymptote is going. Again, no x-intercept, so I don't need any x's upstairs. I just need a bottom-heavy fraction. So f of x will be a over x minus 1 squared, vertical asymptote at 1, following the second order asymptote. But the fact that it's upside down tells me that a is going to be negative. Now the number I gave you 0, negative 2 is the point, which means f of 0 is negative 2. So knowing this and this, can we solve for a? What is f of 0? A over 0 minus 1 squared. Let's take a look at that analysis. So f of x is a over x minus 1 squared. F of 0 is 2. Plugging in 0 for x, f of 0 is a over 0 minus 1 squared. A over negative 1 squared. A over 1. A. Well, f of 0 is a, and f of 0 is negative 2. Well, that's nice. That just means, of course, that a is negative 2. So I can plug that in up here, and I get f of x is negative 2 over x minus 1 squared. Notice if I had an x upstairs, we would have an x-intercept at 0. If I had an x minus 5 upstairs, I'd have an x-intercept at 5. I had no x-intercepts. That's why I don't need to worry about that. Let's take a look at our next example. We want to construct a function for this graph. I have a vertical asymptote at negative 1 and a vertical asymptote at 2. But they are different. At negative 1, going up to the left, down this side. So if that happens, what can we argue? We can say that this is going to be order 1. There's also an asymptote at x equals 2, so I need x minus 2 downstairs. But the asymptotes are going the same direction, down to negative infinity, down to negative infinity. So that means x minus 2 downstairs will have an exponent of 2, whereas x plus 1 downstairs will have an exponent of 1. Again, no x-intercepts. A little hard to see, but that's our reality, so I don't need to worry about the numerator. So vertical asymptotes again at x equals negative 1 and x equals 2. So I need an x plus 1 downstairs and an x minus 2 downstairs. No x-intercept, so no x's upstairs. The x plus 1 downstairs to the first power, again, up on one side, down on the other. X minus 2 to the second power, since they're both going the same direction. Down, down. And I need to solve for a. Now the point I gave you here was 0, negative 3. So that means f of 0 is negative 3. So we have f of x here. We have f of 0 is negative 3. If I plug in 0 for x, 0 plus 1, 0 minus 2 squared. So let's take a look at that. What do we have? Plugging in 0, a over 0 plus 1 times 0 minus 2 squared. 0 plus 1 is 1. Negative 2 squared will give me 1 times 4, or a over 4. So f of 0 is a over 4, f of 0 is negative 3. That tells me a over 4 is negative 3. Solving for a is negative 12, and my final answer will be f of x is negative 12 over x plus 1 times x minus 2 squared. And that will complete this lesson.